Hey guys, I was going to make another video, but this one popped up. The situation popped up, so go ahead and make a video about this power supply. Well, this came out of a Vizio E320i-A0 LCD LED backlight type television. It's not my television. What I did is I determined the board to be bad, to be defective at that location, pulled the board so I didn't have to drag the whole 32-inch television back with me. And it's a pretty simple switch mode type circuit. Power comes in here, goes to the fuse, goes through your RF filtering, ends up in this full wave bridge. This is your main filter capacitor. This is your switch mode circuitry right here. That's the main switching MOSFET transistor. It's a through hole board and surface mount on the back. This is the switch mode controller IC. And my battery warning is blinking, so I better hurry up. And it goes into the, here's the transformer here, switching transformer. This is the secondary side. Very simple because there's only one output voltage. On the older LCD televisions I've been inside, they had the cold cathode fluorescence, so they had to have the high voltage drivers for that. And they often had several voltage rails for different parts of the television, but this one is just one voltage. And here's the secondary. Of course, you have the opto isolator circuit here off the secondary for feedback to the switch mode controller. And you can see here on the secondary, these are all tied together. These two are tied together, these two are tied together. In this rectangular copper area, you see these three connectors, and that goes to these Schottky diodes, and the other end of those diodes are also shorted together, so they paralleled these Schottky diodes together. They're pretty beefy. What are they? SR510 Schottky diodes, 5 amps, 100 volts, and they tied them together and they paralleled these capacitors. You can see how these are connected. So these filter capacitors are tied together. Then it runs through this coil, this choke, and then goes out to the output. And it's a 4-pin connector, but if you look carefully, it's hard to see, but 2 of the pins are tied together here and 2 over here are tied together. So it just feeds the main board a single supply voltage. So that's, to me, that's unusual. I've never seen that before. They might use that television, with a maybe another model has a 12-volt input where you can use it with a 12-volt supply or something. I don't really know what the supply voltage of this is. I can't read these capacitors because they're face down in goo where the numbers are. But anyway, it's a defective supply. I'm not getting any output. And we'll take a look and see if I can figure out what the problem is. Well, it was late last night, so I went to bed. So next day I looked into this thing and found the problem. But there's bad news. I ended up bricking this thing. I ruined it. My fault. I screwed up. And I'll explain what I did in a minute. But anyway, the problem was one of the diodes on the output is shorted. And let me grab this here. Here's a schematic of the output. So you have the Schottky diodes in parallel there, and two capacitors in the output inductor. And I put a small voltage on, kind of backfed the power supply here. Because of the diodes, that would allow the capacitors to charge up, hold a charge if they're working. Well, it was a dead short, so current was going through the shorted diode and through the coil. So I removed these diodes to see which one was not working properly. Well, here's a properly functioning Schottky diode, forward biased. The voltage drop is 0.327 at whatever current this meter is putting through it. So let me hook up the bad one. Well, here's the bad one. Dead short. Even if I flip it around and reverse bias, it's a dead short. So, very easy repair. However, like I said, I screwed up and bricked this thing. What I was doing, I was testing this, make sure the switch mode circuit was working. And I used this scope here. This scope, ground reference, you really should never hook up your scope to line operated devices, non-isolated. This scope is isolated, so I used it to measure it. I was getting a pulse train, just a short burst of pulses going to the gate of that MOSFET. So then I took the radio, set it to AM, brought it near, and I can hear it going bzz, bzz, bzz. So the circuit was actually trying to start. However, because of the short, it was kicking it back off. So what did I do? Well, when I measured with my oscilloscope for the video, I was going to, make the video of it, and I accidentally touched the lead across the gate and the drain. Of course, the drain has 160 volts or whatever on it. That immediately blows out the MOSFET, and the my dim bulb tester goes on bright. And of course, when you're doing that, the driver stage also gets a burst and it blows that out. I cut the gate lead, well, I cut the drain and the gate because I wanted to get some voltage into the it has its own voltage source for the driver circuit here, and it wasn't putting anything out anymore, so I figured I cooked it, ruined it. Yep, I screwed up. Big fail on my part, ruined a easily repairable board. The good news is you can buy these things for 10 bucks. Free shipping. You can get them on eBay. Good sellers out there sell these things that they're either new or recovered and tested working from television sets that probably had a broken screen or some other failure. So yeah, 10 bucks I can replace this thing, so that's good. But yeah, failure on my part, but at least I did diagnose the original problem. Well, that's it for this. Thanks for watching.